First-generation computers. These were the earliest electronic computers, built mainly from the 1940s to the mid-1950s. They used vacuum tubes, which were glass devices that controlled electricity inside the machine. Vacuum tubes made computers possible, but they also made them huge, hot, expensive, and difficult to maintain. A single computer could fill an entire room and needed a large amount of power just to run. These machines were not made for everyday people. They were used by governments, military groups, universities, and research labs for serious calculations. One of the most famous examples was ENIAC, a massive computer used for complex mathematical work. First-generation computers usually accepted input through punched cards or paper tape, and their output was often printed on paper. Programming them was slow because people had to write instructions in machine language, which is the most basic language a computer can understand. Even with all these limits, this generation mattered because it proved that electronic computers could solve problems much faster than humans or mechanical machines. It was the beginning of modern computing. Second-generation computers. These computers appeared in the mid-1950s and lasted into the early 1960s. The biggest change was the move from vacuum tubes to transistors. A transistor is a small electronic part that controls electrical signals, but it is much smaller, cooler, and more reliable than a vacuum tube. Because of this change, computers became faster, used less power, and broke down less often. They were still large and expensive, but they were much more practical than the first generation. Businesses, banks, and government offices began using them for tasks like payroll, record-keeping, and scientific calculations. Another important change was programming. Instead of only using machine language, people could now use assembly language and early high-level languages like Fortran and COBOL. This made computers easier to program and helped more people work with them. Storage also improved, with magnetic tape and magnetic core memory becoming common. Second-generation computers mattered because they moved computers from experimental machines into useful business and scientific tools. They made computing more reliable and opened the door for wider use. Third-generation computers. These computers developed during the 1960s and continued into the early 1970s. Their main feature was the integrated circuit, also called a chip. Instead of building a computer from many separate transistors, engineers could place multiple electronic parts onto one small piece of silicon. This made computers smaller, faster, cheaper, and more dependable. Third-generation computers also became easier to use. Keyboards and monitors started becoming more common, replacing some of the older punched card systems. Operating systems improved, allowing computers to handle several tasks and users more smoothly. This was a major step because it made computers feel less like single-purpose machines and more like flexible tools. Companies used them for accounting, inventory, data processing, and communication. Universities and research centers also used them for science and engineering. A famous example from this period was the IBM System 360, which helped standardize computer use in business. Third-generation computers mattered because they made computing more organized and accessible. They helped computers become a normal part of large organizations, not just rare machines for special laboratories. Fourth-generation computers. These computers began in the 1970s and shaped the computer world we still recognize today. The key invention was the microprocessor. A microprocessor placed the main brain of the computer, the central processing unit, onto a single chip. This made computers much smaller and much cheaper than before. For the first time, computers could move out of large companies and into homes, schools, and small offices. Personal computers became possible during this generation. Machines like the Apple II, IBM PC, and later many desktop computers changed how people worked, learned, and created. Software also became more important. Word processors, spreadsheets, games, databases, and design tools allowed ordinary users to do useful tasks without needing to understand the inner details of the machine. Storage improved with floppy disks, hard drives, and later optical disks. Fourth-generation computers mattered because they brought computing to the public. They turned the computer from a large business machine into a personal tool. This generation created the foundation for modern desktops, laptops, and many digital devices we use today. Fifth-generation computers. These computers are usually connected with advanced computing, artificial intelligence, and more natural interaction between humans and machines. This generation began around the 1980s and continues to influence modern technology. The goal was not only to make computers faster, but also to make them smarter and easier to communicate with. Fifth-generation computers use powerful processors, large memory systems, advanced software, and network connections to handle complex tasks. They can support speech recognition,
image recognition, language translation, machine learning, and expert systems. In daily life, this generation can be seen in smartphones, search engines, voice assistants, recommendation systems, and modern AI tools. These computers can process huge amounts of data and find patterns that would be difficult for humans to notice. They also depend on parallel processing, where many parts of a computer work on a problem at the same time. Fifth-generation computers matter because they changed what people expect from machines. Computers are no longer used only for calculations or documents. They can now help people make decisions, create content, understand language, and interact with the world in more human-like ways. Sixth-generation computers. This is often used to describe the newest and still developing stage of computing, where computers become more connected, more intelligent, and more powerful than ever before. Unlike the earlier generations, this one is not always defined in one single way. It is usually linked with technologies such as artificial intelligence, quantum computing, cloud computing, advanced robotics, nanotechnology, and very fast wireless networks. The main idea is that computers are no longer only separate machines sitting on a desk. They are becoming part of a larger digital environment. A phone, a car, a home device, a data center, and a wearable gadget can all work together through the internet. Cloud systems allow people to use powerful computing resources without owning the hardware themselves. Quantum computers are still developing, but they may one day solve certain problems much faster than normal computers. Sixth-generation computers matter because they show where computing is going next. The focus is shifting from simple speed to intelligence, connection, and problem-solving at a massive scale. This generation is still unfolding, but it points toward a future where computers become even more deeply built into everyday life. Supercomputer. A supercomputer is an extremely powerful computer built to handle massive calculations at very high speed. Unlike a normal desktop or laptop, it is not designed for everyday tasks like browsing, typing, or watching videos. It is made for problems that involve huge amounts of data and millions or even billions of calculations. Supercomputers are used in weather forecasting, space research, nuclear science, medicine, climate studies, and advanced engineering. For example, scientists can use a supercomputer to predict storms, model the movement of galaxies, or test how a new aircraft design might perform before building it in real life. What makes a supercomputer different is not just one powerful processor, but many processors working together at the same time. This allows the machine to break a giant problem into smaller parts and solve them much faster. Supercomputers matter because they help humans study things that are too large, too dangerous, or too complex to test in the real world. Quantum computer. A quantum computer is an advanced type of computer that uses quantum technology instead of only normal computer bits. A regular computer uses bits, which can be either 0 or 1. A quantum computer uses qubits, which can work in a much more flexible way because of the rules of quantum physics. This allows quantum computers to explore many possible answers in a very different way from traditional machines. They are not meant to replace normal computers for simple daily tasks. Instead, they're being developed for special problems that are extremely difficult for even the fastest supercomputers. These problems may include advanced chemistry, new medicine, secure communication, material design, and complex optimization. Quantum computers are still developing, and they are difficult to build because qubits are very sensitive to their environment. Even small disturbances can affect the result, but they matter because they could open a new era of computing where certain problems that once seemed impossible may become possible to solve.